For objective 8, we're back to the unit circle again, but this time we're going to look at it only from the viewpoint of sine. And we're going to use 5 key points. Actually, just 4 key points, because we're going to start and we're going to end right here. So we're going to use the 0 degree. Let's talk about it in degrees first. We're going to use the 0 degree mark, the 90 degree, the 180, the 270, and then we're going to go back to 360 again. So those 5 points, 1, 2, 3, 4, and 5. But now let's think of them in terms of radians. This is 0 radians, and it's also 0 degrees. 0 is 0, no matter how you look at it. So this would be 0 radians. This would be pi over 2, otherwise known as 1/2 pi radians. Remember, going halfway around the circle is the equivalent of 1 pi radian. So that would make this 1.5 down here, and that's why it's 3 pi over 2, because that's 1.5. And then back here where we started, we're not going to call it 0 again. Now we're going to call it 2 pi. So 0, 1/2 pi, pi over 2, 1 pi, 3 pi over 2, and then 2 pi. Now, what are we going to do with those numbers? We're going to look at them, or those angles. We're going to look at them from the sine viewpoint only. And remember, sine is going to be y over r, and the radius is always 1. So it's really just the y value. So we'd be at 0 right here. We'd be at 1 right here. We'd be back to 0. We'd be at -1, and then we would be back to 0 again. One more time. Sine is y over r. And since the radius of the unit circle is 1, then it's essentially saying y over 1, which is y. So 0, 1, 0, -1, 0. Now we're going to transfer that to the parent function of the graph. So here's the parent function of the graph, and the graph that we will be graphing is y equals sine x. And we're going to be using those 5 key points. Now you might see, well, on the x-axis I only have 3 places marked. Well, what would be between 0 and 1 pi? It would be pi over 2, 1/2 pi. And what would be between 1 pi and 2 pi? Well, it would be 3 pi over 2, or 1.5 pi. So these are going to be my 5 key points that I'm going to use. Just like when I went around the circle, there were 5 places that were really important. So what were those 5 places? Well, when I'm at 0, I'm at 0. You could think of this as, actually, if you go back, remember I started, and then I went around and I was back at 0 again, and then I went around and I was back at 0 again for the y values. So I'm going to place a point right there, a point right there, and a point right there. Now, where were we when we were at pi over 2? We were right up here. And the y value of that position is 1, so that would be 1 over 1. So I would be right there. And then when I was down at 3 pi over 2, I was down here. and that's negative 1 because the y value is negative 1. And now I just try to connect my graph as smoothly as possible. And there's my sine graph. There's my parent function of y equals sine x. Okay, so now that we've seen how the parent function works, let's start looking at what we can do to the equation and what that will do to the graph. So on here, we now have y equals 2 sine x. The only difference between this and the parent function is that leading coefficient of 2. So the amplitude equals 2. And all that means is the graph goes higher and it goes lower. But it doesn't shift left or right. So it's a pretty easy graph to graph. I'm going to use my same 3 0 points. There's a 0 right there. There's a 0 right there. And there's a 0 right there. But instead of going up to 1 and down to negative 1, we're going to go all the way up to 2, and we're going to go all the way down to negative 2 at these values of x, pi over 2 and 3 pi over 2. Other than that, the graph is pretty much the exact same thing as this graph. So we make it, and there it is. There's y equals 2 sine x. My next example takes us back to amplitude 1. Notice there's an invisible leading coefficient of 1 in front of that sine. So I'm back to amplitude equals 1. So the top and the bottom of my graph is now positive 1 up here and negative 1 down there. But remember what this x plus pi over 2 does. Like all of our other graphs, anything that was in parentheses or absolute value bars with the x always went opposite. So this is going to indicate a shift of pi over 2 to the left. And you can see that's what I did. I took our normal 5 points on the parent graph, these 5 right here, and I shifted pi over 2 to the left. So on this graph, I didn't need a negative pi over 2. But if that entire graph is shifting to the left by pi over 2, then its starting point is now not here at the origin, it's right here. And we're still using the 5 main points, but they've all shifted pi over 2 to the left. So this would be my middle, where I would come back and cross 0, and this would be where I would end. And right here, I would be at the peak of 1, and down here, I would be at the lowest point of negative 1. And I'm just going to connect those into my sine graph, or my sine wave, and there it is. Now this next one can be a little bit tricky. Our amplitude is 1. So I know I only have to go up 1 to get to the peak and down 1 unit to get to the lowest point. There's been no left or right shift, but this plus 1 at the end of the equation is doing something. It's shifting the entire graph up 1 unit. So what would normally start at here at the origin now starts at 1. In fact, my middle line right here now is the line where I'm going to have 3 points. I'm going to go up to 2 at pi over 2. I'm going to come back to 1 at pi. I'm going to go down to 0 at 3 pi over 2. And I'm going to go back to 1 at 2 pi. So my graph looks like that. My last example is going to be this one, y equals negative sine x, or y equals opposite sine x. Now, the leading coefficient in front of that sign is a -1. It doesn't change the amplitude, so the amplitude is still 1. You don't call it -1, but the negative sign does do something. It reflects the curve across the x-axis. So if we're not changing the amplitude, and we're not shifting left or right, and we're not shifting up or down, then we're almost back to the original parent function that starts right here, and then it has the 3 places where it's at 0. But instead of going up, it comes down, and then it goes up. And so it actually looks like this. That's y equals opposite sine x.